Hi folks, welcome back. So as we build agents and harnesses these days, I think one of the most important design decisions is what parts of your overall workflow, the workflow that the harness or the agent is following, what part of it is deterministic and can perhaps be formally checked and verified versus what part of that workflow needs models, needs some natural language understanding, reasoning planning, and so on, things that you make LLM calls for. And I've talked about that particular design decision a lot in previous videos. That's kind of one of the main thrusts of what I'm trying to do with specialized harnesses. But today I wanted to take a look at another paper that is doing philosophically something very similar. And what they're trying to do is take agent instructions and formalize them into a proper enforced policy language. And the goal here is, just like I said, instead of looking at probabilistic guardrails where you just try to prompt and pray, you want to encode your guardrails into a language that properly, formally encodes these guardrails and then actually enforces them at runtime. In the case of this paper, the language they're using is called Cedar. And just to give a 50,000 foot idea of what Cedar is, so Cedar is a formal policy language where the three main concepts are principle, action, and resource. So the principle is the person or entity trying to perform a certain action, and the thing the action is being performed on is the resource. So if I'm trying to read a file, I would be the principal, the resource would be the file I'm trying to read, and the action would be read. And Cedar is a language that formalizes these kinds of access policies. And what the authors are trying to do in this paper is take the typical way you describe an agent, which consists of a system prompt, a bunch of MCP tool definitions, and other descriptions in natural language, that taking all that and going through a refinement loop, a generator critic loop, kind of the standard thing you do in an agent loop. But this is outside the agent. This is before you build the agent. You put it through that loop to produce a policy written in Cedar. So the input to this generator critic loop is your agent description. And then in this loop, they try to encode parts of it into Cedar, and then they go through this generator critic loop. And there are two different things that they're using to critique and then improve the Cedar policy. The first one is what they're calling a hard critic, a deterministic one. And this is just the Cedar parser and compiler. And the Cedar parser will tell you if it is well formed, if it has syntax errors, etc., etc. And the other one is what they call a soft critic. This is your typical LLM as a judge, which will look at the proposed Cedar code, will look at the NatLang descriptions of your policies and try to tell you if it matches the intent of your policies, the policies that were expressed in natural language. And you go through this loop to come up with a good set of Cedar code that encodes the policies and tool calls and accesses that your agent wants to do. And of course, the whole point is that then at runtime, for the steps that for the steps where the agent is actually accessing some resource or making some API calls or tool calls, you will invoke the Cedar code to check if that access or that API call conforms to the policy you want, as opposed to just trying to leave it as a prompt in natural language. And so that is a deterministic policy check that happens at runtime. And of course, not surprisingly, when you do this against some baseline policy checks compared with earlier agent strategies that basically just use prompts, you get a much, much higher block rate. So that was a quick look at a paper that is trying to take agent instructions and policies, but then encode them into a proper formal language that is actually enforcing those policies at runtime. But the point I want you to leave with is that as you're building agents and harnesses, you really should be thinking about not just sending everything to the model, everything to the LLM with a prompt, but about what parts of your flow can be extracted into some either deterministic code or deterministic formal languages. All right, I hope you enjoyed that. If you like content like this, consider subscribing, like the video, and I will see you next time. Thanks.